Okay, so go in the modern enterprise. First of all, what is a modern enterprise? I'll talk about that. I'll talk about my experience at SoundCloud, which, spoiler alert, I consider a modern enterprise. I'll talk about how my experience kind of generalizes to this class of like organization or company. And ultimately, what I want to talk about is what I think, in my experience, Go needs to succeed in that kind of place. So actually, before I get started, I'm curious, show of hands, who considers like themselves part of a startup in general? I guess since this is the campus, that's kind of what it is. For other people, are you like part of much larger organizations like Google? Okay, yeah, sure. Are there any like consultants or contractors here? Okay, cool. Just curious. Okay, so modern enterprise. What do I mean by that? Basically, I'm trying to classify a group of organizations which I find meaningful, important, trendsetter, this kind of thing. And so for me, this is kind of what I mean. A modern enterprise is a group that's, or a company that's almost certainly tech related in some way, almost certainly consumer focused. Because of the way the financial incentives are structured in our world these days, they probably have hockey stick growth, or rather they rely on that to kind of keep the money coming. For me, I sort of an arbitrary cutoff, but I'm going to say it's a group with around 100 engineers or more. You could maybe cut it down to 50, but at some point you need a certain critical mass of people so that your practices and procedures change fundamentally. And I think I'm going to say around 100, it might be less. And another thing that's kind of happened recently is that, in my experience, all of these organizations have adopted or are starting to adopt service-oriented architecture. Okay, so broadly, here's some companies that may or may not qualify. I'm going to say Google kind of doesn't qualify because they're too big, and the things that they do don't trickle down, so to speak, to the other groups. Amazon, you can kind of make the same claim. They've both been in the game for a long time. Etsy doesn't qualify for me because they actually run a monolith, and so for the purposes of this talk, it's not so interesting. So I guess what I'm focusing on is this class of company. Twitter's quite big. I think they're like 1,500 employees or something, 1,500 engineers. Netflix is around that. Maybe there might even be bigger, I'm not sure. SoundCloud, it might be a bit aspirational that I put us in that group. We're not nearly that big. We have about 120 engineers at this point, company size of around 300 people. And we're planning to double that in the next, 18 months or something like this. So these are the big players, I would say, but I mean, in this space, there's actually a lot of people. If you reduce some of these requirements or reduce the headcount requirement, you see a lot of companies, and these are just the ones that I know or I'm pretty sure are using Go. There's a lot of companies in this space. And I want to highlight these and emphasize, I think these are what I'm calling the modern enterprise, right? These are companies whose decisions and whose like thought leaders kind of drive the market, or at least as I see it, they influence other decision makers at smaller organizations. So the decisions happening at these organizations, I think, are setting the tone for the technical conversation that we're all having in places like this, other meetups, other language groups, this sort of thing. Okay, so that's my pitch. Let me talk a little bit about SoundCloud. Just a quick run through of how we've evolved technically. In the beginning, there was the monolith. This is pretty standard, I guess. If you're at a startup, how many of you would say that you have kind of a monolith-ish kind of architecture? No? That's quite good. That's quite good. We ran this way for a long time, Ruby on Rails, standard thing. And then at some point, several years ago, we started breaking out services. The first service, I think, was basically the search service. That seems to be how things go. And then over time, you end up breaking out kind of a lot of services. And I think this is what most people mean when they say SOA, or I'm going to claim it is. This is a service-oriented architecture. If you keep going down this path, you start breaking out more services, you start inventing new services, and it kind of starts looking like this. And I guess this would be like, if you had to draw a distinction, this would be what people call microservices. I've heard someone say at one point, like, Pico services. Has anybody heard of this? Yeah, I can't imagine what that would be, like a nightmare, I guess. Or like nano services, or, yeah, anyway. So getting back here, this is already like super complex. You can imagine like we have, I don't even know how many, at least 100, maybe like 500 services running in our infrastructure. And that's already a lot to handle in sort of a distributed systems context. So what we started doing about a year ago, maybe a bit more, is lining them up and giving them kind of roles, classifying them. When you arrange them like this, you can kind of group them. And this is what I'm going to coin the term like structured services. So what is like structured services? I'll go into a bit more detail here. What I mean is basically structured RPC, because all these services are talking to each other in kind of defined ways, but that's the key thing that's important to kind of recognize, and that's what I want to focus on. So at SoundCloud, the way it works is this. At our top layer, internet-facing, more or less, we have a set of specialized APIs. So we'll have one API for the iOS client. We'll have one API for the Android client. We'll have one API for the website. We'll have one API for the mobile website. And the reason we do this is we want to specialize the kind of representations that we send back. What you see when you load SoundCloud, the iOS app, is fundamentally different than what you see when you load SoundCloud.com. And we want to leverage like those differences. We want to leverage that specialization to make things as good as possible on each of those interfaces. So we have relatively few of these specialized APIs kind of at the border. And all they're interested in doing is working on these materialized views. Next layer back, we have all of our business logic. And this is the biggest layer by far. Here's things like product features. The stream, for example, will have a business logic service responsible for generating the stream or stream-like things. And then at the bottom, we have things that deal with the data model. So the social graph that's kind of inherent in any relatively big web company these days. The data model for like our track objects, or the concept of an affiliation between users, something that you like, something that you repost, things like this. And actually the data model layer is by far the smallest layer. They're the most specialized and single purpose services. So let's consider the life of a single request. You open up your iOS app, you hit refresh or whatever. So that comes in here, and probably there's going to be some widgets on that view that you need to like get information for. So this top layer is going to call out to some business logic layer. It's going to make some request to some data service layer. Based on the results of that, you might need more information to other business services, and then so on and so forth, down to the data layer, back up again. So in the single request, in this example, which is totally manufactured, we have one request that's hit a total of 9 services and made a total of 14 RPCs. And this is in no way abnormal. In fact, this is pretty minimal. We have many things that do maybe an order of magnitude more than this on a single request. And that's a lot, right? And when you start having 100, 200, 500 services in your distributed system in your organization, you need to have pretty strong conventions to make any sense of what you're building. So let's look at a single one of these like request response cycles, client to server, or like service to service actually. What do we need? Well, in the client, for sure, we need application metrics. Same thing on the server. We need metrics on the connection itself, on both ends, both on the client's perspective of the RPC and the server's perspective of the RPC. And so we need to be able to like differentiate between them, compare and contrast. On the server side, we need things like back pressure to make sure things don't get overloaded. We talked about that a bit earlier in another talk. Similarly, on the client side, we need things like circuit breakers to make sure we don't overload our network when we have partitions or what have you. On the connection itself, we want to be able to support different transports. So HTTP JSON is great for prototyping and quick iteration, but at some point, I don't know the exact numbers, but we have certainly a double-digit percentage of our CPU cycles in our data centers devoted exclusively to marshalling and unmarshalling JSON, and that's across languages. We want to reduce that, right? So we want to be able to support protobuf or thrift or Cap'n Proto or something, and we want to be able to make experiments and swap them around. There's basic high-level stuff like authentication and authorization between services. This is especially important at the border, but it's also important when you're dealing with things like, I don't know, promoted content or stuff that involves money. It's very important. And then for the system as a whole, you want things like service discovery so that a client knows a pool of service to talk to. You also want things like request tracing, as was also kind of mentioned. You want to be able to take a single request and follow it through this huge distributed system that you've kind of created, perhaps without knowing all the details as you were creating it. So we want all these things. And in fact, like, pretty much all these things are non-negotiable. We need all of these components. We need to be able to understand them. And we need to be able to like reason about them as we're building the system up. So the question becomes, how do we do all this stuff, right? And I want to go back to like this list of companies and maybe derive some or extract some information there. So Google and Amazon were early to the game. They kind of do things their own way. I assume they have some internal tools, internal libraries that accomplish all these things for them. Etsy's a monolith, so it doesn't really apply, or they have their own ways. But I want to focus on these sort of middle tier companies again. Twitter was early to the game, and they built a lot of stuff in Scala, and they built a whole collection of libraries which they put under the umbrella of Finagle. Netflix also, they were a Java shop for a long time. Now they're kind of mixed. And they have their own set of less bundled libraries. It's all kind of open source. They have different names. SoundCloud, we were in this space about a year ago, and it kind of saddens me to report, that's why I put these stars here, that we followed in Twitter's footsteps, right? And so today, the majority of those boxes, those multicolored business logic boxes, are implemented in Scala. And the majority of them are using Finagle to handle all these things that I identified. So in that sense, like, Go lost, right? Stars, again, we haven't lost forever, but this is the state of the world today. And I think in a lot of those other smaller companies, depending on how much smaller they are, they're going to be looking at these trendsetters and they're going to be coming to sort of the same conclusions. So let's reflect on this. How did Scala win in this sense? From my perspective, it won because it had a great success story with Twitter. Great, depending on your perspective, but Twitter's definitely like growing as a business, right? And that's a really good sell. That's a really good sell to somebody making high-level technology decisions at a modern enterprise company. It has reasonable performance, by which I mean not always embarrassing performance. Scala gives you great business domain expressiveness in that you can implement the ideas that you have without too much friction. There's a flip side to that we'll come to in a second. And Scala got a lot of mind share. Like, it's very easy to find blog posts and articles and reasonable people having reasonable discussions about Scala idioms, for example. But Scala is not a panacea. There's terrible things about Scala. It has an objectively terrible toolchain. Are there any Scala programmers here, actually? 1, 2. Get out. No. I've dabbled. And, well, we have a lot of Scala programmers at SoundCloud, and they all agree about these things, I think. Actually, there's one guy in SoundCloud, his name is Georgi, and he loves Scala. But out of like 75 Scala programmers, that's not a great ratio, I guess. Yeah, Scala has an objectively terrible toolchain. The compiler is just bad. It's just a bad compiler. SBT is just a bad environment to work in. It has a confused language design, by which I mean it's sort of like designed by committee and designed by committees that don't agree with each other almost ever, right? There's like the Scala Z, academic people. There's like this whole pragmatist like industry group that has some influence as well. And as a result of this, I'll argue that nobody really understands the language. Even at a high level, I think people do cargo cult programming in Scala, especially around when it has to touch like SBT and the build tool chain and that sort of thing. So there's room for like upset here. And part of the reason I'm so sad that Go lost is because I think Go like solves all these problems, right? There's some great things about Go. Specifically for us, or in this context, Go has an objectively awesome tool chain. There's nobody who programs in Go in anger, as far as I'm aware, whereas in Scala, that's definitely true. Go has a coherent, considered design, which I think we all appreciate. I'd like to really emphasize that static native binaries play really well in like a DevOps world. Can't state that enough. The Go, the services we run in Go are on average an order of magnitude more efficient than the services we run on the JVM. And by efficient, I mean like resources used per unit of work done per request, something like this. We have really great and strong conventions at the micro scale. I'll explain what I mean. And we've had a lot of success stories at sort of a small scale. Like this company has rebuilt this service in Go and achieved, whatever improvement. But it's not all awesome. There are some things that give people pause when they consider Go. Youth is one thing. Go's 5 years old now. That's cool. That's still pretty young in a lot of people's eyes. There's nothing to fix that except time, of course, but it's something to consider. From where I sit, when I'm trying to pitch Go in these meetings, Go has an overemphasis on primitives, and I mean low-level primitives. I'd like to address that. There are big caveats in Go as well. Besides kind of the elephant in the room, there are other smaller things that nevertheless like give people kind of like make them turn their head and be like, really? And those things need to be addressed, right? Maybe not fixed in terms of fixed in code, but at least discussed so that people have a better idea of the pros and cons. And I want to argue that we don't really have good higher order conventions, higher order idioms. We don't have any big company scale success stories yet. So sort of the stuff I want to talk about here is I want to say that we should embrace and emphasize this positive stuff, but we should spend some energy on the negative stuff, on the minus stuff. And so that's what I want to like dive into a little bit. I want to talk about what I think we need as a Go community to get Go to be successful in this modern enterprise sort of context. And I put a star here because this is just totally my opinion. And what I hope to do here is spark some conversations. I don't claim authority on these matters. I only can claim my own perspective and my own opinion. So, a list, some things. We need fewer blog posts about request muxers. And I don't mean to like throw shade on people who are having a lot of fun building like web frameworks and ORMs and like this kind of thing. It's cool, right? And like it's cool to write a project that you can totally get your head around and get excited about and post to Hacker News, and somehow you get 150 upvotes and your GitHub repo has 1,000 stars in a day and suddenly everyone's talking about it. Like it's cool, but maybe we can focus our energy in a bit more intelligent way. Maybe we can write blog posts about other things, higher order things. For example, I would love to see more blog posts about things like composable interface design. Like using the concept of basically like HTTP handler chaining, except more generally. As an example, wrapping behaviors of things so that each layer, each coherent layer of the thing you're building is its own single purpose like interface, composable interface. I have a friend who's going to submit a talk to GopherCon about this sort of thing. It's just an idea, right? But the point is to walk up the abstraction chain a little bit and think about building larger scale, higher order things. Similarly, has anybody heard of the context package, right? It's really cool, right? The things you can do with this are super impressive, but the only like documentation or like people talking about it that I've heard so far has been the post on the official Golang dev blog. And it's great, but I'd like to see other people using this thing and see what their idioms are, see what patterns fall out of that. Similarly, like in the application, instrumentation, DevOps kind of world, I'd like to see more blog posts about the proper way to do things at scale. And so instrumentation is one thing that I don't see a lot of people talking about, but there's all sorts of things like, I don't know, there's a huge list of DevOps like topics that we could be discussing, and we could be discussing idiomatic Go implementations of these things. And I think through that process, it would be very convincing to a large class of people how Go is almost the perfect language for this kind of software development. In general, I would argue we need more blog posts about elegant patterns and what they enable. And for me, the thing that pops immediately to mind is the post that Rob Pike did about the scanner lexer, the way he built the scanner lex, like functional scanner lexer. Dave Cheney wrote a blog post about and did a talk about functional options, I think. These are great, right? And these are really cool things. They're still kind of primitives in a sense, but they're a bit higher order. And I'd love to see a lot more of these things. All this talk about blog posts is really just to build mindshare, right? It's to talk about problems that apply to the modern enterprise and can maybe convince some minds in those spaces. I asked around at SoundCloud among the Go fans on what sort of things they'd like to see, and this was a topic that came up quite a lot. We have this concept at SoundCloud of enterprise open source, which means all of our teams are kind of responsible for their own repositories, and they interact with each other in an open source model, meaning if you want the search team to implement a feature, you should open a pull request and implement that feature yourself. Similarly, if you decide you want to work on another team's project, like you have full access to everything without a barrier of some kind. And so you can learn that way and then maybe change teams later on. So in that model, it's kind of fine. That's how the broader internet works. And so we have really no problem doing vendoring. Like we vendor all our dependencies. For a while we were using subtrees. Now I think we're switching slowly to GoDep with the -r to rewrite the import paths. I think the Rocket team is doing this as well. It seems to be okay. But that said, we have this universe, right, which we totally control. We import third-party dependencies, but we write all our own code for the most part. And it would be great if we had a way to leverage that like constraint to build some benefits on top of it. Things like controlled lockstep upgrades of packages, code base wide renames, maintaining tip compatibility. We could have a continuous build server. We're working on this. We could have a continuous build server that constantly, every 5 minutes, pulls all the dependencies for updates, runs a build, tries to produce all the artifacts, and then mails people when they fall like incompatible with tip on all their deps. So this is stuff we could be doing, we're working on. It would be great if other organizations using Go could talk about this sort of thing, could talk about what their build stories are. And so we kind of converge to something that makes sense. But really, what I really want to propose in this forum is that we need a higher order framework for structured services. So let's go back to this diagram, right? Here's everything that happens when two services talk to each other. And if these were both Go services, what would we need here? I can imagine pretty much all of these topics being packages in a repo, right? And let's start with like package metrics, right? It would be great if we had a package metrics that was kind of canonized, and it had concepts like gauges, counters, and histograms. Because we want it to be idiomatic Go, it would be great if it treated xvar as like the source of truth. You would always push to xvar first, and then package metrics would take that as its source of truth and then export it to different instrumentation facilities like, I don't know, Graphite or StatsD or OpenTSDB. All of these backends could be pluggable depending on what you were running in your architecture, but it would be a common like concept. For all of these packages, I think it's really critical that we consider prior art. And in this domain, I think prior art means Coda Hale. He's kind of the metrics guru. He tended to work in JVM languages, but now I understand he's got a bit of a Go bug himself. At SoundCloud, we have a monitoring system called Prometheus, which we've just open sourced. It encodes a lot of good concepts, in my opinion. Package metrics would be something I'd love to see. And let me again remind you, this is just my opinion of what should be in here. I'm happy to hear other people's opinions later or offline. On the server side, all those things that are the domain, the consideration of the server, I think need to be encoded somehow. Package server might be something, probably wouldn't be called package server, but it might be something that declares and enforces these conventions that I say we need. It has concepts of back pressure, of connection pooling, and for each of these things, we would want to be able to plug in multiple strategies depending on the kind of architecture that we've built for ourselves. Another important thing that package server would need to do is integrate and publish to a service discovery mechanism, whatever it happens to be. Here there's a lot of prior art. Twitter's Finagle kind of covers a lot of this stuff. In Netflix's stack, I think the server component is called Carillon. I haven't looked at it in great detail. When I gave this talk a couple days ago, a couple of people came up to me and they said they've worked on their own independent things in Go that kind of accomplish most of this stuff. And that's cool. I want to hear about it, right? And I think we need to have, as a community, a more considered and collaborative discussion about this, where hopefully, not that we need to canonize a single way of doing things, but that we kind of understand the parameters of this stuff as a group. So ultimately what I would want to do is, like, if I have some service, I would want to define it as an interface. And like, these are maybe the high order things that it does, but if it means, if in order for me to get what I want, connection pooling, back pressure, blah, 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 means that I have to like change my interface definition, I'm willing to do this, right? I'm willing to pay this tax. What I want to try to emphasize here is that all these things on this diagram with the line going from the one box to the other, this is stuff that the modern enterprise absolutely requires. And what I'm trying to do here is like start this conversation about higher order idioms, higher order practices that encode these things and pay and like force you, if necessary, to pay a tax to get them. On the client side, it probably is very similar to the server in that it package client would declare and enforce these conventions that I'm talking about. They would encode rate limiting and circuit breaking and all these important things with multiple pluggable strategies. It would need to subscribe to the service discovery mechanism, and again, a pluggable backend. Here, there's other prior art. Finagle on Twitter's side captures most of these semantics. Netflix has a project called Ribbon, which is the client side of their thing. I keep referencing service discovery. This is a hot topic, and there's lots of ways of doing it, and no single way seems to be emerging as the best way. So I would expect a service discovery package to support multiple methods. At a base level, like the distributed model is using something like DNS SRV records. A lot of companies now or infrastructures are moving to a centralized model, which is console or etcd, which is like a consensus protocol-based service, configuration service. I guess Kyoto Cabinet would be like a hybrid distributed centralized model as well. If you follow Airbnb, they have something, it's not in Go, but it's also a hybrid model where they have a single like source of truth, which they distribute to HA proxy load balancers on each node. And so the applications always talk to localhost on like a known interface, like that's the contract. And then the actual distribution of service information is abstracted away. These are all valid methods, and I don't mean to say one should be used over another, but yeah, we should maybe have a common interface to those things. Similarly, I want to be able to, in this like amazing world that I'm describing, switch out the transport layer. So HTTP JSON to get started, maybe that's enough for a huge class of people, but I want to be able to switch to like protobuf or thrift or package RPC or Avro or Captain Proto. I want to be able to go over not just HTTP, HTTP2, pure TCP, 0MQ maybe. These should all be interoperable, right? Because we have this nice OSI layer separation. There should be no problem with swapping these things out. Maybe we can leverage GoGenerate to build these bindings, possible. Prior art here, I guess there's a lot of stuff in the standard lib. I'd love to know more. If anybody has seen any code in the wild that builds stuff like this, I'd love to know about it. And if we have all this infrastructure, right, if we have clients and servers talking in this way with all these conventions that we can leverage, then we can maybe build a package inspect, right, and get introspection of a running system. We'll pay a cost for this stuff, right? We'll pay the cost of like threading all these request IDs through all of our requests and instrumenting all our code at like entry points and exit points and all this stuff. But I'm willing to pay it, right? And because I'm willing to pay it, I can get a lot of cool stuff out of it. So I don't know, the Google people have Dapper, the open source world has Zipkin, even something as low level as JMX, or maybe reflected in the new like process trace system that's coming, the Chrome visualizer. Like this would all be really cool to have globally in my entire infrastructure. So this is my vision. I don't claim it's like unique or definitely right or anything. But I do claim that this is the direction we need to start moving in if we want to see Go gain adoption in what I'm calling the modern enterprise. In general, I want to argue that we need to start climbing the ladder of abstraction. We spend a lot of time building microservices and like one-off tools and utilities. And I'd like to start having conversations about the next order up. And I think we can do it idiomatically. I think we can do it without sacrificing a ton of performance or a ton of efficiency or whatever. I think it's what's necessary next. So let's talk. If this sounds at all interesting to you, please like tweet at me. I'm gonna hopefully, if I get enough interest, set up kind of like a discussion consortium working group, and start getting real, start building some concrete things and seeing how this evolves. So that's my talk. Thanks for listening. I'm happy to take questions if anybody has them, or comments, or complaints. Yes?
When you start a new service in SoundCloud.
So the question is, when you're starting a new service, how do you decide between ecosystems, and specifically, how do you convince people that Go is valid, something like this? Yeah, I think this gets back to what John mentioned. It's like at some point, it has to come from a high level that it's okay to choose between N choices, right? And for us, we had a period where there was like a Cambrian explosion of languages and ecosystems. We were running Haskell in production for a while. We were running Clojure, like anything you can imagine. And that was great for our company at the time. It let you specialize. The important part was that if you had a service that needed to do something, you could pick a language, a tool chain that allows you to specialize exactly in that sort of domain. And that was great. And now we've like reduced, right? We have probably 3 or 4 runtimes, and Go is one of them. But the important part for like choosing them is to have like a small group of people who are willing to like push forward on Go or on Scala, and then like at a high level, you at some point do have to say it's okay to choose Go for this sort of thing. Now, to Go's benefit, like any intelligent developer is going to be able to make meaningful commits to a Go project after literally 1 day of studying the language, and that is never been like refuted or combated at SoundCloud. And if you're having trouble, I would say that's a good line of attack, so to speak. Maybe that's helpful.
I think from my experience, I've worked with content creators.
So the question is, how would you advise perhaps less technical people to consider Go as an alternative ecosystem? What are you building exactly? Like, why would the implementation matter for those content people?
They've been working with they're musicians who failed to sort of agree with particular entities.
Yeah.
And then they want to go free.
Okay.
Sort of promoting the open source route.
I see. So it's more like at an API layer or an interoperability layer. Yeah, I mean, I guess I would answer it in a very similar way, in that like Go is so easy to pick up and become productive in that it's worth a shot. Like, give it a day, literally, and see where it takes you. It's my experience that in the creative class, it's often very easy to get somebody to spend a weekend learning something new, processing JS, or I don't know, like a certain library or framework that promises like big results. And if you can make that kind of transition as painless as possible with like support, tutorials, help when it's necessary, this has been very successful for the broader like SoundCloud community, I can definitely say. But I guess your question is very specific in that it depends on a person-by-person basis ultimately.
Most of the people working with use SoundCloud?
Yeah. So, yeah, sorry, a bit general advice there. One more, yeah?
In your slide, you mentioned some big caveats that you perceive in Go. Can you briefly outline what you think those are?
Well, there's the big one, right? And I won't even speak its name in this place. It doesn't really, it's not as big a problem as you'd expect, but it is there. And I guess my point is that since it's there, you kind of have to have a response to it. So, okay, that one.
You should probably say what it is.
I should probably say generics and then just let it sit over the room like a heavy cloud. Yeah, it's like an interesting topic. Anyway, it's not really for here. Other ones. I think a lot of it has to do with this concept of primitives that I touched on. Like, people want to be able to say, I have an HTTP server that abides all of my like organization's conventions. And when you start saying like, okay, well, did you put a CORS handler in your handler chain? They're like, what? Why should I have to do that? So I guess it's like more a question of like education, or like getting people to, the thing that you always see when people learn Go for the first time is like, you're thinking about the problem in like the Ruby way, and therefore you're encountering friction. So you need to think about it in the Go way. And this is the sort of caveat that I see all the time, that I have to kind of explain to people. Your past experience isn't directly transpilable to this new ecosystem. And so it's really all about idioms and patterns and conventions. I'm sorry I don't have more concrete things to say. I'm kind of drawing a blank, but yeah, that's kind of what I mean, I guess. Going once, going twice. All right, I'll be hanging around, so if you want to talk, get at me or tweet at me or whatever. Thanks again.